The light in the workshop here is pretty ordinary. Not bad for a human, but pretty dark if I'm filming stuff. And as I get older, actually, even for a human, I'm just finding that sometimes there's just not enough light for the little tricky ones. So I was just thinking maybe I could upgrade the lighting here. So a sane person would probably go to the local hardware store and for $20, get some lighting, little LED panel or something, or would be good. There's certainly a lot of them around. Tradies use them all the time. But not being a sane person, I thought instead I get hold of some of these LED Cobs, and this one is supposedly 7 watts. So I thought, well, what I could do is maybe put them on a heat sink. I mean, they're already on a, like a little aluminium plate, but if you're going to pump some decent wattage through them, then maybe something more like this guy. That's a decent heat sink, isn't it? And then what we could do is maybe put a couple of them on here, and then you could have them pointing towards the staging area here and providing a little bit more light. Say one from this side and one from that side. So the first thing I did was to solder up one of these guys and see what sort of voltage and power requirements that they require. So there's a little bit of information available on the site where I bought them from, and it would indicate that the forward voltage for the whole deal is around the 20 volt mark, which seems extraordinary. But let's just plug it in and have a look. So I've just got a little 10 watt, 10 ohm resistor in there, just to keep things on the up and up. So can we see that? Yeah, that's okay. So let's try turning it on. So we've got 5 volts coming in, and that's not enough to do anything really. So we'll just maybe crank that up a little bit and see what we can. Here we go. So 5 volts will go to 6, 9, 13, still nothing, 14, 15, 16. Oh, there we go. And just a little bit of light coming on. I might take a photo of that so we can see a bit more closely and maybe have a guess at what's happening there. All right, so we're on 15 volts here, and we'll just crank that up. That's 16. Oh, it's just a little bit of light there. Let's go to 17, is too much. So we might try and say around 16 and a half. And see if we can't get those little guys to appear. Yeah, I can see them coming out now pretty good. Yeah, that's not bad at all. So let's go exactly 16 and a half, and we can see, yeah, I can see them pretty easily. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 on the outside and 5 on the inside to give 14. So I'm guessing if it's 21 volts is the entire forward voltage for this cob, that these must be in pairs. So you've got probably 7 in series of pairs, and that would explain, because probably most likely to have a forward voltage of around 3 volts. So 7 lots of 3 volts is at 21 volts, and then having them in parallel, having the pairs in parallel would allow you to put more current through. So, all right, well that helps. Let's just see if we can crank it up a bit more and get some light out of it. So it's this guy. There we go. And we'll go to 17 and a half, so it's coming on pretty well there. 18 and a half, 19 and a half, and 20 and a half volts. And let's see what we're drawing. So it is, okay, so around 80 milliamps, 1.6 watts. It's pretty respectable. Let's go up a bit higher. So we'll go to 21 and a half and see what we've got there. 2.8 watts. I'm probably on around the 5 watt mark, I'm thinking, for a 7-watt light, so it's not too stressed. Just bearing in mind that this is going through a 10 ohm resistor. So I'll keep going. So these are 22 volts, come up around the 4-watt mark at the moment. And just probably go around the 5 mark. Oh, okay, so we're getting some current limiting happening there. Yeah, you can see that. Didn't quite spot that there, but that is actually current limiting at 200 milliamps. And I think that's probably around about 2/3 of what they're rated to. Or actually might be pretty close to what they're rated to. Anyway, I'll check that on the, well, I don't know if you call it data sheet, but certainly the data that came with it on the website. All right, that gives me an idea. Let's wire a couple of these up and see how it looks. Right, so what can we do? Well, yeah, so let's go back to this idea here of having them on a big old heatsink, and maybe what we could do is just wire these up in parallel. So there'll be 2 here and then 2 on the other side. Let's see if I can do that. On the other side. Yeah, and then let's try and get that so it's not flaring so much. There we go, it's not too bad. And then if we run so parallel all the way through and then connect it up to some sort of device a little bit like this, I guess. This is obviously a complete power supply unit with the lot, but there's also these other little guys, which might be more useful. So I've had these for a while now, a few years actually, and this might be the perfect use for it. So if I'm correct, then I think what we've got here is we've got an input. Let's have a look. So input on this side. So input here, so maybe I could hook up one of those laptop power supplies that comes in at about 25-ish volts or 30 volts, it doesn't really matter. I think you've got your volume, your voltage control, and you've got your current control. I'm not sure which is which. So I'll have to do a little bit of research on that. And then you've got your out. So if your out was coming to these lights all in parallel, that might work. I might get that wired up and we'll check it. All right, so I found this switching power supply in the back of the shed, and we've got 32 volts coming in at 1500 milliamps or 1.5 amps. That should be about perfect. All right, let's give that a whirl. All right, so what have we got here? 32 volts coming into our little buck converter, and at the moment it's putting that out as 15 volts. No current flowing at this stage because that's not enough to activate these 2, which are in parallel in this circuit as well. The 8 volts coming in at the top, that's just to feed this meter. So that's coming down through here and feeding the meter. All right, so let's start cranking up that voltage and seeing what happens. So the LEDs should be coming on. You won't see any signs of that just yet. Oh, there we go. So now we can see some light coming in. Still no measurable current at this stage. There we go. Now we're starting to get some current flowing through. And we'll go through to, let's say, 21 volts. Let's see if we can readjust that. There we go. That's an interesting effect. And we'll just keep cranking. Oh, I think we've got some current limitation happening there because I can't crank that any higher. Yeah, that's pretty much it. So that's pretty good. All right, so let's just focus on this over here. There we go. So it's about 0.35 amps. Yeah, that's pretty good. So I'll wind that back again. and you can just see that fading away. I think that's going to work pretty well. So, and I like the idea that I can track it using this guy here too. So I think what I might do is put this converter and this meter in the same circuit, and that will be useful to find out what current is being drawn and at what voltage, and then adjust accordingly. I guess there are scenarios where you might need different lighting effects as well, with more light or less light. So yeah, I'm pretty happy with that. Let's do that. So instead of 2 of them, I'll get 4 of them, and I'll make up a little box for this guy and that guy. All right, a slight rethink of the project. Well, not too much really, but I did find these things at the local tip shop, which is where people go to recycle stuff. So these were $3 each, and comes with a globe, which is a screw globe. Yeah, so what's that? That is 60 watts, 240 volts, AC, and it's got the little screw-in adapter there, and all the way through here, and then a couple of holes here to attach, which will be nice to sit up underneath. Oh, a little bit of dirt there. $3. So that's not bad. So what I've done is I've taken that the little screw fitting out of there, and yeah, so I can actually poke wires through here. And I'm just thinking actually that this aluminium block, which I'm going to use as a heatsink, might even fit in there, and perhaps I can screw that in. So I might actually put a couple of the globes on here, or the cobs I should say, and try it. Mount one of these and see if it'll actually work. This will then become part of the heatsink. Not that it'll probably need it, but also it'll direct the light, which I think will be pretty awesome. So yeah, good pickup. I'll clean that up and solder one of these up and see if this will work. Yeah, it looks pretty ugly, but it'll do the job. So I'll tap it on this side and tap it on this side. So I'll take this out now and put the cobs on there, and then put the wiring through. Pretty cool. Little dab of heat paste to put this on here, and then I'll have to wait until it is all fixed down, and then I will solder it up. Here's the case being printed out, which is yeah, probably got another about 5 or 6 hours to go. And in the meantime, I've cleaned up the bench, and the light is being provided by the actual cobs themselves at the moment. So there's 4 7-watt cobs in there that are providing the lighting, which is, yeah, it's pretty awesome. And at the moment I'm just running it through the old ZK 4KX. So it's on current control at the moment, which I think is around 250 milliamps. Let me just check that. Yeah, 250. And it's set at 21 volts, but running at 19.4 at the moment. And yeah, it's been running for about half an hour or so, and no dramas on the heat or anything like that. So next job is to wire up the converters that I've got, and then put it all together when the box is printed, and we're good to go.
Yeah, so there's a lot going on here. Really what I'm doing is I'm paralleling the 2 buck converters. So one of them is going to provide the 20 volts for the lights, and the other one's providing 15 volts for the voltmeter / ammeter, and both from the same power supply, which is the 32 volts coming in from the right hand side there. So yeah, the last thing to do, I guess, is to just have a quick look at the FreeCAD design that I used. I can make the STL files available if anyone is interested. And once the STL files are available. I just use Ultimaker Cura to do the actual slicing. Pretty standard in the end. The sort of parameters that I used, I think 2mm, it might be 0.16 millimeter nozzle, 40% infill, and around about 10 or 11 hours or something of printing to get that done. Yep, so coming together nicely. Next thing will be the final product.
This is the backside view without the back on at the moment. I'm still 3D printing the back, but you can see the digital voltmeter / ammeter there, which is secured at the front, and then the two boards, one which supplies power to the LED and one which supplies power to the digital ammeter / voltmeter. And you can see there the switch coming in from the side. So let's have a look at the front. Try not to focus on the hot glue skills, which haven't improved over time. Sorry about that. But, you know, the actual lights themselves are working very fine, and, yeah, providing all the light that I'm going to need for that area. So that is the circuit working for this week. Quite a good project. Really enjoyed that. And looking forward to many hours of well-lit other projects as well. Catch you next time.